Hello everyone, so for today's lecture, let's look at a case study, visual analytics of COVID-19 data. So here is the outline for today's lecture. So first of all, we'll look at some background about the visual analytics system. So I'll introduce you some examples to let you know what can we do from a visual analytics system, and also some real-world examples or cases. And after that, I'm going to go through a real-world example or case study to show you how to use visual analytics system to analyze the COVID-19 data. And we will follow a typical workflow which contains 3 steps. First of all, we need to collect the data and analyze the data types. So this is a what step in our book. And secondly, we need to look at why, which are the tasks that we want to conduct during our analysis. So we also call this requirement analysis. And finally, we'll look at how to map your data to the visual design space. So we will need to prototype our design and also implement our prototype. So during this part, I'm going to introduce you some additional content we haven't covered before. So first of all, we need to talk about the streamlit layout, which is super important to create a visual analytics system. This enables you to lay out your different visualizations into different views or columns. And secondly, we need to understand how to customize the styles in the streamlit. So this is because by default, streamlit doesn't allow you to create some customization. For example, if you want to change the color of your font, or if you want to change the background of your container, you need to use these customization styles rather than the default behavior. So finally, we will talk about geospatial visualization. So this is because we already talked about some other visualization types such as line chart, pie chart, or bar chart, but we haven't talked anything about the geospatial viz. However, this is quite commonly used in the real world. So I will give you a very high-level introduction about the geospatial visualization and also how to create one in the Altair. Okay, so let's dive into the details now. So first of all, a little bit of background knowledge. So visual analytics system. So this is So here we have some examples. So the first one is the COVID-19 dashboard by the Johns Hopkins during the pandemic. So this is a super famous because it allows you to see all these patterns, trends during the pandemic. So basically they have a major visualization, which is the geospatial visualization that allows you to see the case distribution among the world. It has all of countries, and also this dot represent how many cases among each country. And also they have some histogram shows the weekly cases, weekly deaths, and also this is a weekly dose. So this is the vaccination information. They also have some other text information on the top and on the left side, show you some basic statistics and also data about the COVID-19 scenario. So we also have this New York Times COVID-19 dashboard, which they present some daily cases, vaccinations, and also you can filter this data. For example, if I want to know about the Franklin County, I can just search Franklin County, okay? So through this dashboard, we can see here we have 2 significant waves here. First of all, about this, I think it's 2020 December, we have a lot of cases, and also last year winter, we also have a lot of cases here. And they also provide a geospatial visualization as well as a lot of trends changed in the Franklin County. So in addition to this COVID-19 usage, we also have some visual analytics system that allows you to conduct other analysis. I couldn't open this, but basically this is a visual analysis system I created before. This system is trying to explain some machine learning models we created for predicting the heart disease of some patients. So the basic idea is that we have a RN model, and this RN model intrinsically is hard to interpret. So we have this visual analysis system to interpret this model. So first of all, we have this overview page which try to shows you all patients we have. So we have two different colors, means whether this patient was be diagnosed as heart disease or not. Then we have their demographic information, and on the right side, this is a knowledge map we used for our model, including the chiral relationship between the drug and disease. And finally, we have this patient history view, which shows you how this visits will affect the final prediction. For example, this red color means, okay, this visit is very super important to the final prediction. And also for each visit, we have a specific value corresponding to the drug, which means whether this drug is helpful or not. We can conduct some what-if analysis, say, if I add a drug at a specific time, would this final prediction results become better or not? So that will help our researchers as well as the medical doctors to understand the models better. So finally, we have this 3D visual analysis system. So this is actually developed by one of students advised by Dr. Chen, who is work on this quantum physics data. So this is so-called quantum dot, and also we have a lot of quantum vectors. They have different orientations. So a lot of physicists are using this software to check their simulation data and also find some new patterns inside the data. So taken together, all of these visual analytics systems try to present you a interactive user interface that allows you to interact with your data, to dive into the data and find some insights. So they're super helpful for a lot of users and also data analysts. So for today's lecture, we will create a similar dashboard, but for our COVID-19 data. So, so the final results will look like this. So we will have a COVID-19 dashboard, and we will have several visualizations here. First of all, we will have a geospatial visualization that shows all the cases. This is accumulative cases until a specific date in the Ohio state. So we have all the counties in the Ohio state. And after that, we have a, this is a line chart, shows all the daily cases, all the daily deaths in the Ohio state. So we can select a specific county or all counties. We can also select whether we want to show the data all the time or we just want to see the last 90 days data. And we can also specify what specific data we want to check, whether this is going to be a daily case or a daily death. So on the bottom side, we have another panel. So this is corresponding to the Ohio State University data. So we have the last 7 days cases, test, and the positive rate. We also have a bar chart to show you the daily cases in the spring semester. And also finally, we have this vaccination rate. So the bottom side is kind of a replication of our OSU dashboard, but here I try to simplify. And here I also added geospatial data because I want to let you know how to create a geospatial visualization. So this dashboard is not perfect. I have to admit it because I didn't really spend too much time. I spent about 1.5 days. So, but the point here is that I want to give you a starting point for your final project. When you work on your final project with your group members, you will, first of all, you will have some specific scope or goal. So you may want to use COVID-19 data, or you may want to use some other data set. For example, if you have some collaborator working on a material science or economic or the policies. So you can apply your own data and try to visualize it through our workflow I will introduce later. First of all, you need to collect data, then you design a prototype, finally have something like a dashboard. So the beauty of dashboard is that it always enables you to group a lot of different visual design together, and you can have some relationship between them. For example, I can see the correlation between this geospatial data and also the daily cases. For example, if I click one county here, I show some specific daily cases in this county. So this can be one of interactions you can implement. I didn't implement here, but you need to do it if you want to do it. If you want to do it, you can use the altair selection feature to connect the two figures together. And also we have a lot of widgets that allows us to filter our data. So this interactive features could allow your users to get a better understanding about the data. Okay, so the first step of our project is going to collect the dataset. So I know we already have a lecture introducing you how to where to find data and how to collect data, how to generate data. But for the COVID-19 data, we have our unique data sources, and I would like to introduce them to you. First of all, we have our OSU dashboard. So as I mentioned before, my dashboard is kind of similar to this one because I try to replicate the bottom side. And this dashboard has some other things because it also has this different semesters. However, the data they provided online here, these Excel documents are not complete. They only provide partial data. I try to get the raw data from them, however, they just said unfortunately they cannot provide the raw data. So you can give it a try by sending email to this address, but I would say for some reason they cannot share the raw data here. Okay, so but you can still get some partial data, for example, the recent daily cases at Ohio State. And so the next part, this COVID-19 data sources, this is provided by OSU. They list some common source that you can use to find the COVID-19 data, such as the Central Ohio Resource Hub, and also they have some public health data, including the tracking project, the New York Times data we will use for this project. And the next part is our Department of Health. They also provide some data sets you can download here. And this data set are quite detailed because it contains all this gender information, including the male and female, and also the age group. For example, if we have more daily cases for the older group or the younger group. Okay, so finally, so the next part is the data we're also going to use for our project, the New York Times data. So if I click this link, click this link, we can see here we have another data set. So this data set, it has this cumulative cases and deaths among the US, and also it has the county level data, which means we can have a very detailed data and do some selections over counties. Finally, the CDC also provides their own data set. So there is the CDC data hub where you can download data here. So that's all data I searched online about the COVID-19 dataset, but you can definitely find more dataset here. Okay, so now after introducing these data sources, I would like to let you know some dataset I collected for this dashboard. So in summary, I collected 3 datasets. The first of all is a cumulative cases and death data from the New York Times. So the data looks like this. So first of all, so it has 6 different dimensions or attributes. First one, we have the date, which is the specific date. And then we have the county name, for example, this is Cuyahoga. And we have the state, we have this fix. So you can think of a fix is very important because it's a unique number or unique identification for each county. For example, the Cuyahoga has this fix, but Stark has a different FIP. So using this FIP, we can connect many different data sources, such as the geospatial data, because if you look at the geospatial data, they also have a same ID called GeoID, which is the same to this FIPS. And then we have the cases. This is the accumulative cases, and also we have days. So since we have these cumulative cases and days, we can calculate the daily case by subtract the later day with the first day. Okay, so the second data we are going to use is this OSU daily cases. So this data look like this. So it's different from the data format I will show before. So it's more like a horizontal one. So for each column we have a specific date, and for the other rows we have the daily cases under that day. And finally, we have a very simple data. This is the OSU vaccination rate. We have the fully vaccinated or partially vaccinated people. We also have this unknown count, which means we don't know whether these people already been vaccinated or they just didn't report. But basically, this is the vaccination rate. So taken together, we will use these 3 data sets to create our visualization visual analytics systems. Second step, requirement analysis. So the basic idea here is that given the dataset you collected or the goal of your final project, you can ask a set of questions about your data. Or if you have some other collaborators, for example, a domain expert who is work on the policies or the material science or on other domains, he or she has any questions about your data. So for example, towards the data we just collected, we can ask some questions like, what are the geospatial distributions of the COVID-19 cases among the Ohio counties? We can also ask about the evolution of COVID-19 in the Ohio state. So, for example, what are the trends, outliers, and also features? We can also study the trend or evolution of COVID-19 in the OSU. So, in particular, we can even see what is the correlation between the OSU and the Ohio state, right? So, all of these questions can be dive into different tasks. If you look at the Tamara's book, for example, what are these summary comparison tasks? What are these lookup tasks? So that's the requirement analysis you need to go through with your group members. So the next part is our prototype design. So once you have the questions or the tasks you want to conduct or answer, you will try to create some prototypes. So by you can simply doing this by draw some sketches look like this. So you can work with your group members, you try to draw it using your iPad or just like a white paper, try to brainstorm the design ideas. So for example, towards the questions I want to ask, first of all, I want to create a geospatial visualization look like this. Although I know the shape of Ohio is more like a flag rather than Ohio state. But the basic idea is that you try to draw some visualizations here and know what are these functionalities. Then we have these daily cases among all the counties in Ohio. And then we have the OSU daily cases, look like a bar chart, and we want to create a donut chart to show the vaccination. So in creating or designing this prototype, you need to always think about some questions, including are the visualizations we design effective and expressive? So effective basically means we have learned about the visual encodings and what are the rank of their effectiveness. For example, the lens should be more effective compared to area when we work on a racial estimation task. So we also need to consider about the expressiveness, whether you want to use two visualization or just one visualization to represent all the information within the two visualization. And we also want to have add some interactions to our visual analytics system. This is because we want our user to interact with their data to have a better understanding about the data. Finally, is layout. So as you can see here, I try to divide the whole canvas into two parts, the top part and the bottom part. Each part contains two visualization, but in the real world setup, you may also want to think of your own layout. You can create a more complex layout or simpler layout. So that is about the prototype design. Next step, let's look at the implementation part. So since we already have our prototype designed like this, and the next step is going to implement it. So the first step is about data pre-processing. So this step is super important because the data we just downloaded from online. So I already store all the data I downloaded online to this folder called data folder. So this folder contains all the data I collected from the OSU dashboard and also the New York Times. So as you can see from the OSU data port, we can download all this XS data. And also I also download a US counties data. This is the largest data from the New York Times, which is about 100 megabytes. Okay, so since we have this data and the original data format might not be what we want to use for our final project, so we need to do some data pre-processing. So the data pre-processing can contain several different things. For example, we might want to calculate additional attributes. So for example, the US counties data only contains the accumulative cases and the death cases and the days. So if we want to calculate the daily case or daily deaths, we may want to subtract one day from the other day. So that is so-called additional attribute calculation. So we also want to handle some missing values or abnormal values. For example, if I have some data missing in my dataset, or if dataset originally has some errors, then I need to write some code to handle these errors. Finally, we may want to find some additional datasets. This is important because, for example, when we want to create a geospatial map, in addition to this original raw data, we also want to have some geospatial data. So we need to find those data online and serve as the data source for our map. So now let's look at how to pre-process our data. So first of all, I'm going to create a terminal. So I'll click this new terminal and change my current environment to streamlit, right? And streamlit. Okay, so now I'm under the streamlit environment, and also I'm going to create a new data pre-processing .ipynb. So this format is actually the same as you learned from the Google Colab, because I want to see how this data looks like using this interactive user interface. So first of all, I'm going to import some essential Python libraries such as pandas, spd, import, for example, I'm also going to use NumPy because NumPy is super important in the data pre-processing. So import these two libraries. Okay, so after that, now let's load our data and see what does it looks like. So the first data I'm going to deal with is this US counties data, which contains the cases and deaths for all the counties. But as you can see, this data is super large, but the target we want is Ohio data. So we need to filter the data a little bit. So we need to, first of all, load the data. So the data is equals to, so I'll just copy the data I wrote before to this part. So so now as you can see, I'm trying to read this US counties data to this data, and then I select the state equals to Ohio and reset index and save the sub data to a new CSV file once we run this part. So, oh, sorry, I need to first run this one. Choose streamlit, and it should import all these libraries. Actually, we don't need this terminal. And then we can run this part. Okay, it's finished. As you can see here, now we have our Ohio counties data. All these counties come from Ohio rather than the United States, the whole United States. So that's the first step we want to do. And next part is, since we already have this Ohio data, we can see how it looks like. So let's say our data is going to be the subdata.head5. Okay, so this is our data looks like. So we have 6 attributes, but now what if we want to calculate daily cases and daily deaths? So in order to do that, we can add a new code block and write a function to deal with this data. So the basic idea to calculate the daily case is that so we have 2 consecutive days. For example, here we have this March 9 and March 10. We want to use March 10 to subtract this March 9. For example, that means in March 10 we have new cases equals to 0, and 11 we also have new cases equals to 0. As so for the deaths we follow the same strategy. So in order to do this, first of all, let's try to create a dictionary for our table. This is because, for example, if I try to write a for loop to calculate the new cases for this day, I need to look up the previous day. However, we also need to look up the county with the same name. That means we need to use this date and the county as a key, combine them together as a key to look up the corresponding cases and deaths. So I write a function by myself. This is the function I always used. So this is called create table dic by 2. So the basic idea of this function is that given 2 fields name, for example, the fields can be date, county, And also the file name is going to create a dictionary of this data for you, so you can look up the data by yourself. So if I add this function here and try to fold it, run it, add a new block here. So what if I want to create a dig for my Ohio counties data? What I can do is to write a county dig equals to create a table dig2 and specify date and the county as 2 keys here. And then I use this file name as my input. So if I run this code, and it's going to create this dictionary for me, and we can have a test on this dictionary. So it may take some time because the data is still quite large. Okay, so now we have our data, and we can test. So suppose I want to have this date equals to 2020 March 9, and I use a hyphen to connect the 2 key here. For example, the first key is date. I add a hyphen here to split the first key and a second key. So if I want to see Cuyahoga, and then if I run this one, you can see it will return me a array with all the fields inside this row. So that is a customized function you can also use for your project. By creating dictionary, you can look up the specific data here. Okay, so now let's write the data pre-processing code. So the data pre-processing code is look like this. Let me copy my code wrote before. So I'll copy the code here. So first of all, I need to import another library called datetime. So the reason of doing this is because the first column, the date column, is actually a datetime column. In Python, it's going to read it as a string. So we need to convert it to a datetime to do more data operations. For example, if you want to compare to date, if you want to find the day before a specific day. So let me import this datetime library. Okay, so now we have our datetime here. So the basic idea of this data pre-processing is that, first of all, let's read this Ohio counties data, and then we remove all the unknown counties because we're not going to use these counties. There's still some data. This is so-called error data or abnormal data. Then we write a for loop here. For each row, we first get its date and store it using the datetime attribute. Then it's going to convert this data to a Python datetime format. After that, what I'm trying to do here is that I'm going to check what's going to be the county. So this is going to be the county name, and what's going to be the previous date, because we want to see, for example, we have March 10 data, we want to see what's going to be the March 9 data, right? So we need to calculate the previous day. So that's what's stored in this previous date variable. Then I specify a key by concat these two variables together using a hyphen. This is used for our key lookup. So now let me check if this key is exists in my county dictionary we created before. If it's not, it means this day is actually the first day, because if the March 8 is not in this dictionary, that means it's not appeared, or we do not have specific data. That means this day is actually the first day. So we just use this case as a data case. So we assign data case equals to this case. Otherwise, we're going to calculate the difference between the current day and the previous day. So we use the current day cases minus the day of the previous day cases to get the case difference. However, this case difference might less than 0. This is because sometimes the Department of Health, they have some data errors when they're collecting the data. So for example, the first day they may have 5 cases, and the second day they may only have 3. This is because they may have some errors during the first day. That means there has some data abnormality in our data. So if I found some difference less than 0, I will assign it to the NumPy null value. Otherwise, I'm going to assign the difference to our data cases. And then finally, I'm going to store the data to this Ohio counties CSV. Actually, let me rename it to Ohio counties CSV and run this code. But in the real world practice, you may not want to override your original data look like this, because I know the code here is correct, so I override the original data. So you can just use a new data name here. So now if I go to my data, you can find we have additional 2 attributes here, one called daily cases, one called daily datasets. So now we have all the new data attributes here. So this is the data pre-processing for our first data. And secondly, we need to deal with our OSU data. So first of all, we have this daily cases at Ohio State, as I mentioned before. Okay, so this is the XLSX data. This is the Excel data. So I am going to do is that I will store this data to a CSV file. So Pandas can also deal with this Excel file, but the CSV file is going to be easier to deal with Pandas. So if I open this file using my Excel, so you can see here, and then what I can do is just save as a CSV. For example, I can search CSV here and store it to my desktop data. So now I have daily cases at Ohio State. And I can do the same things for my for my vaccination summary. I can also store a CSV copy for this data. So now if I go to my data, and we can see we have a CSV file, and we need to convert the data format of this one. So what we can do is, so let me check my code before. So we can write another function called convert OSU data. First of all, we will read our data, and after that we need to drop our first column because we no longer use this column, the semester column. And then we transpose the data by use data T and we set an index and rename the column names to a date and case. And finally, we also need to convert this column to a data time column, because currently you can see this data format is like a string, but we want to convert it to a standard Python readable format. And finally store it to this OSU cases. So if I run this command, and then you can see here I already converted the original data to this format, which can be easily used in the altair. And for the last step, the vaccination rate data, because the donor data will require you to have 2 categories and also their values. So what I'm going to do is open this Ohio State vaccination summary data and just rename it. For example, here I can rename it called category, and here call it count, okay? Or maybe just a value. It's more intuitive. So now we have our data here and store this file into a CSV file. So we can save it and go to our desktop data and store it as a CSV file. Okay, so just click yes. So now we have our vaccination data as a CSV file. So that's all we need to do for the data pre-processing here for this 3 datasets. But for your final project, I think you may have a different format. So try to think of how to convert the data, deal with this error data or missing values, and also some abnormality in your dataset. Okay, so that's the first step, the data pre-processing step. So since we already cleaned all of our raw data, the next step is going to implement this dashboard. So if we look at this dashboard, before we implement the interface, first thing we're going to do is to create a streamlit project as we did before. So let me first create a new folder on my desktop, call it, and let's just call it, maybe we can call it COVID-19 dashboard, okay? So after that, we can just load this folder to our Visual Studio. So actually what we can do is to drag this data into this folder. So now we have a full folder with all these files. So if I open my Visual Studio again, and drag this folder here. So now, as you can see, I have all these files, data files. And under the root folder, I'm going to create, so this is not the root one. So I'm going to create a file called app.py. So this is the same as we did before. So, and import some essential libraries such as streamlit as st, and import pandas as pd, import numpy as np, and also import the altair, which is a visualization library we're going to use for this project. And also, that's going to import the data time because we're still going to process this data time format. Okay, so once we import all of this here, what we can do is to import the data we created before. So in order to do this, first of all, we can add some comment here. The first step is going to loading dataset, okay? So the first dataset we created is this Ohio counties data, which is used for our top part, this geospatial visualization, and also this line chart. So let's read this data using the pandas pd.readcsv command. So, and let's specify this as data Ohio counties. Sorry, I have an N here. .csv, and the encoding type is going to be UTF-8. So I add this parameter because sometimes our data may contain some characters are not the pure English. So it's always safe to add this UTF-8 because it has more capability to deal with these other characters. Okay, so once we know the data, we can check if our data was loaded successfully. We can use the st.dataframe to check the first 5 rows of our data. And then, in order to launch the streamlit, so we can open our terminal. And after that, let's activate our environment, activate streamlit, and use the streamlit run at p.py to call the program. So now we have our program here. So, and actually let me put it into a different desktop so you can better see it. So now you can see we already import our data here. It has all these 8 attributes with daily cases, daily deaths, cases, and also other attributes. So another thing we're going to do is to convert this data time column, as you can see here, from string to data time object in the Python. The reason is because when you use the PD, the pandas to read this CS file, it's going to convert this date column to string automatically. However, that is not what we expected or desired since, because we want to use the data time so we can do more operations such as check whether this day is the day before the other day. Okay, so in order to do this, pandas provide a function called toDataTime. So if you still remember in lab 1, we use a lot of toNumeric function. Here we have another function called pd.toDataTime function. And after that, we can just convert this column to a data time type. So that's what we need to do for this dataset. And another thing we might need to do is, because we're trying to add a selection box here, which contains all the county names. So in order to do this, what we can do is to get all the counties. So let's just use counties equals to, should be the list and data county dot unique, because we want to remove the duplicate county names. So that's going to be our counties, and let's just write down this counties and see how it looks like. Okay, so if I go to the website and refresh it, so now we have all the counties here. So one thing we need to know is that in addition to all these counties, we also want to include additional one called all counties, because we want to have a summarized data. So in order to do this, we can add another one to this list. Just call it all counties plus this list. Then we will have our new counties. So if we refresh it, so now we can actually refresh it now. So now we can see the first one is going to be all counties. Okay, so this is the first data set we're going to import, and let's copy it here and remove this one to load our second data set. So the second data set is going to be our OSU data. So let's call it OSU data equals to, I can just copy this line, and which equals to this OSU cases.csv. Okay, so and similarly, we're going to convert the data column. So do something like this, and let's test what does it looks like. So if I refresh the page, so now we have our OSU data. As you can see here, we already converted this data from a string to date time. So it shows look like this with this hours, minute, and second. And also we have the cases for each day in the Ohio State University. Okay, so finally, the data set we haven't imported is the vaccination data. Let's call it vaci data equals to pd.csv. So, so this one is going to be this. So we can rename it and copy the name here. So suppose we have this data, and let's see what does it looks like. Okay. Oh, it has some error. Category value 0 blended. How do you position index? Oh, the reason is because, this one. So because it only has 2 rows, we can do this. So now we have our category and value. And also you may notice that here value is actually a string rather than a numerical number. So we need to convert this one to a numerical number. So let's do this. So by using the toNumerical function, vaci data and value equals to pd.toNumeric. Yeah, second one. Okay. And let's set it to always vaci data value. Okay. So if we refresh the page, okay, so you may see some error here. Unlabeled parse string at position 0. This is because it has a comma within the string. So in order to deal with this situation, we need to add another parameter for this pd read CSV file called thousands equals to comma. So the pandas will know how to parse our data. So if we refresh the page again, now we can see here it's already converted the string to a numerical number. Okay, so that's all data we want to import here. Oh, by the way, we have another data because we're going to show the vaccination rate here. So we need to calculate it. Okay, so the way we calculate this number is going to be vaci rate equals to, so we can first of using this vaccinate data dot add. So we want to use the first row and its value divided by the first row plus the second row. That means the total cases. This one is a vaccinated case. This one is going to be the total case plus, and this one should be 1. Okay, so now if I just print this one, so you can see a float number, but it has a lot of decimals. So in order to only keep 2 decimals, we can use this round function. So I'm going to make it wider. Okay, so 2. Oh, maybe it's not here, but here. Okay, and in order to show it on the screen, we can also convert it to a string, which is going to be add a string function. So now we can see a 0.93 here. So that's going to be our vaccination rate. Okay, so that is all the data loading part we have done so far. And the next step we're going to do is to implement the interface. Okay, so interface. So let's look at our interface. First of all, we have this title called COVID-19 dashboard. So let's actually write it. We can use string.header, and it's going to be COVID-19 dashboard and see how it looks like. Okay, cool, we have this dashboard. However, one issue here is that we may want to change the style of this title because as you can see here, we have a gray background, we also have this red font, and also this is a bold font rather than the regular font. So in order to do this, we have to use some specific feature provided by Streamlit called Markdown feature. Because Streamlit doesn't support to update the style of this stuff directly, we need to use some experimental feature. In order to do this, first of all, so let me go back to my slides, and I introduced it here. We need to use some web technologies we introduced before, including the HTML and the CSS. So if you still remember, HTML is like define the structure of your web page. CSS defines the appearance of your web page. So in order to create the HTML and CSS in your Streamlit, you need to use the string st.markdown command, with the first parameter is your HTML code, and the second parameter is going to be unsafe allow HTML equals to 2. And let's see how to do it. So what we can do is instead of write st.header, we can write st.markdown and write some HTML code here. And for the second parameter, let's just copy it here. Okay, so I copy it. And for this part, let's write some HTML code. So if you still remember, HTML is constituted by a lot of tags. For example, the table tag represents a table, the div tag represents a container. So we define a container called div. And inside this div, we add another tag called h3, maybe which means the third level header. So if we have another h3 here, and just copy the string here, and refresh our page. So we can see another header, but it's h3 header, so it's a little bit smaller than the original one. But the beauty here is that we can define something called style and write some CSS code. So the first step, I'm going to change my background div. Let's say we can use another gray color, and you can just refresh your page and see now we have a gray background. So if you don't know where to find this color, you can just search something like, so here I add a comment, search hex color. So you can convert the RGB color to a hex color, which is more commonly used for the web page. And the next step, we're going to change the color of our title font and also the font weight. So we add another style for this h3 equals to, for example, first off, let's change the font weight equals to bold. And in order to add another style, we use a semicolon, and we change this font color equals to, actually it's not font color, but just color equals to, let's use a OSU red color. So if I do so and refresh my page, you can see now I have this stylized title, and I can remove the first one. So that's how we create the, that's how we customized our Streamlit. So this method is quite commonly used in Streamlit because Streamlit still doesn't support customization for these colors or these other styles. And once we have this title, let's see how what's going to be the other components. So go back to my page here. So one thing you might already notice is that the width of this web page is a little bit from what I have here. This one is much more narrow than the original one. So the reason behind it is Streamlit by default use a narrow page setup. That's very similar to when you're using Word. You can set up your web page, or you can set up your page width and height, right? But Streamlit by default use a narrow layout. So let's change it to a wide layout. So Streamlit actually provides one function called page setup function. So you can use set page config. And here we can specify the layout equals to white. So if I do so and refresh my web page, so now, oh, it has some error. So let's see what happened. st.set page config. And it says, and that's called first streamlit. So you need to call this one at the first streamlit command, which means we need to move it here. So to set up the page. So now let's refresh our page. And now you can see we have a much better layout, which means we can have more space to draw our visualizations instead of the narrow one, okay? So the next step is going to create our layout. So the layout is very important in the Streamlit because in order to combine these different visualizations in a compact way, rather than just put them row by row, we need to consider what's going to be their position and how to combine them together. So in order to do so, Streamlit provided a function called column function, which has a parameter called spec. A spec can be an integer or a list of numbers. So you can use integer or floats in this array. So the column function is going to help you create some layouts. For example, if I use st.column2, just use integer here, it's going to divide the current page into two parts equally, the column 1 and column 2. While if I use the st.column3, it's going to divide your current row into 3 parts. And if I use an array rather than the integer number, what's going to happen is that, first of all, it's going to calculate the ratio between these two numbers or a set of numbers. Then for the whole row, first of all, it's going to divide the whole row to 4 parts, 3 plus 1. After that, it will assign the first 3 parts to column 1 and the rest of 1 part to column 2. That's how Streamlit columns did to create the layout. So once I introduced this layout concept, let's take a practice here. So suppose you are a designer. You're a developer that you're supposed to create a dashboard look like this. So this is from the Streamlit website. So you can see, first of all, we have some widgets on the top. Then we have this geospatial visualization with 3 submap. And then we have a bar chart on the bottom. So in order to create this visualization, how are you going to use the Streamlit column feature? Maybe think of it for 20 seconds. So and then I will give you the answer. Okay, so let's go back to our practice. So in order to use the Streamlit column, the first thing we need to do is to define a set of Streamlit columns. So here, as we can observe, first we have the first row, and let me try to draw it here. So this is going to be the first row, and let me change this one. So this is the first row, okay? And we need to divide this row by 2 parts, right? By 2. So in order to do so, we can use Streamlit columns and set an array into the parameter. And this one is going to help us divide this one. So let me do this. So first we have our first column here, and then we have our second column on the right side, right? So in order to create the second row, this is going to be our second row. We need to specify an array contains 4 elements. The first element is a little bit bigger, and the rest 3 are a little bit smaller. And finally, we can specify the whole column as a single part in the third row. So that's how we use the Streamlit columns to create this layout. So I hope this practice could help you understand how to create a layout for our application. So let's go back to our application for now. So first of all, we have this widget panel. We have 1 widget for this spatial visualization, and we will have 3 widgets for this line chart. So that means we have at least 4 columns. And also note that we want to have some space between these widgets. So we have 1, 2, 3, 3 white space. So we want to have 4 plus 3, 7 columns here. So let's implement it for now. So if I go back to my code and write something called, so first of all, before I create the columns, I'll add a container. So streamlit provides a command called st.command container, which allows you to separate different containers. That is just a container for all of things, all visualizations appear there. So what we can do is we can specify 2 container, one for the Ohio data, one for the Ohio State data, okay? So let's define our first dashboard. Maybe call it Ohio panel equals to st.container. And another important thing I want you to know is that in the streamlit, in order to organize your code and make it become cleaner, we always use this with context keyword. So then we can, with Ohio panel, we can write all of this like this visualizations, this widgets inside this widget. This can help you organize your code, make it hierarchical. So the first thing we're going to do here is to define the columns equals to st columns, and we're also going to define 7 numbers here. So I'll define something like this. So you can see the first one is going to be the slider widget. Then I have white space. Then I have this county selection, which is still become longer. So I set it 2.1, and I have another white space. And now next step I will have this time. So the time is a little bit shorter, so I can make it 1.2, have another white space, and for the case type, so 1.2 again. So now I have 7 columns. And in order to draw these widgets under each column, what I can do is first use this with context. And with columns 0, this is going to be an array. So now you have your first column, and we can define a start time of your slider. So here we have this slider, and we want to have the date, right? And by default, we want to know which date we want to use to show all the data. This is a cumulative case data. So I define a start time variable equals to streamlit slider, and the text here is selected date. And in order to use a slider, we will specify 3 columns or 3 parameters. First of all is a minimum value, so it's going to be data date dot minimum. And the second one is going to be data date dot maximum. This is going to be, this is going to be data. This is going to be the earliest date and the latest data in our Ohio case CSV file. And let's set the current date equals to the maximum date. So that's how you specify this slider. Okay, so if we run our program, let's see what happened. So we have an error here. It says that we have a key error. So the reason behind this is because the streamlit actually only supports the day date, which means the precision should be the day. However, when we use the PD to data time, it's going to give you the precision as second. So it has hour, minutes, and second. In order to do so, we can add another function called date function. This is going to help you remove the minutes, hour, and seconds. So if we run our code, so now we have this streamlit slider, and you can select a specific date here. Okay, so and finally, we have our start time, and we want our data to be filtered by the current time. For example, if I select if I select the current date, I will show the data of this current date. So if we look at our data here, so we have our Ohio counties data. So we have a lot of dates, and we need to filter this data by the date. So what we can do is actually So let's say the current data is equals to date.log, and say date equals to what? Okay, so it should be equals to start time. Okay, so that's how we select a specific date. So give me a second. So suppose I'm going to print this one. Just use st date frame. Current data. Okay, so and refresh the page. So now you can see we don't have anything here. So the reason is because the data is still different. Here in our data, it has this minute and second, but the start time only has days. So in order to convert it back, what we can do is to use pd dot to data time to convert the start time to the one we want. So if I refresh the page again, and now you can see we already select the data only 2022, and also the March 22 data. So we have all the data in this day. So let's remove this one. So the second widget we're going to put it here is a county widget. So the county widget is going to be the county equals to column 2 dot select box. Okay. And in order to use select box, we need to have set 3 parameters. The first one is the name, and the second one is going to be a list that contains all the options you want to have. So we already calculated the counties here, which is all the counties plus all the list of counties in Ohio. And then the third one, we're going to assign a key to this parameter to help Streamlit know which selection box we're currently using. So if I refresh the page now, so we have the second widget here. So we have all these county names in Ohio. So the third one is going to be this time option. So in order to get this one, what we can do is to create another one. Let's just call it time span equals to, here we should use the fourth column because we have another white space, and call it radio. So in order to use radio, we have 2 parameters. The first one is going to be its name, and the second one is going to be the options. So we have all times, and also the last 90 days. So, okay. So if I refresh the web page, so now you can see I have the third one. And similarly for the last one, which is going to let us choose the type of our data, we can add another radio button here. So I'm going to add one thing called daily type. So it's going to be another radio button, and the name is going to be type. Here we have 2. One is our daily cases, the other one is our daily days. So that is also the name for our data. So we have these 2 columns in our data, daily cases and daily days. Okay. So now we have all the widgets, and let's see how our interface looks like. Okay, so it seems that we assigned it to the same column, so we should assign it to the 6th column. So now we have our all of our widgets, and the next step is going to create these 2 visualization. The first one is a geospatial visualization. So in order to create a geospatial visualization, first of all, we need to understand some basic knowledge about geospatial visualization. So let me go back to my slides. This is the final part. So a little bit introduction about geospatial visualization. So I won't dive into details, but still I think this part is very important because I saw in the first several lab, only a few of you use the spatial visualization. I think the reason is because you don't know how to use it, and the format of geospatial visualization in Altair or Matplotlib is a little bit different from other like bar charts or line charts. Okay, so first of all, the first thing you need to know about geospatial visualization is typically we store our map in a computer or in a database through two formats. One is called vector map, one is called raster map. So for the raster map, it's based on something called raster tiles. I can show you a demo here, I'm sure. So the raster tile is saying that for the whole world, we're going to create a pyramid to store the data. First, we have the highest level, which shows the whole world. Then we split it into split into 4 tiles on the second level, which is going to give our higher precision or resolution. Then we split again and again. We have different levels. For example, here I have the third level, which show most of the world here. If I zoom in, now you can see I'm in zoom 4. If I zoom in again, zoom 5, go to Ohio. And if we just keep zooming to our Columbus and even Ohio State, you can see now I'm already in the zoom 14. So the map are stored in a set of tiles in a pyramid structure look like this. So that is how raster map stores. And also another thing notice is here all these things are the images. It's taken from the satellite or it's drawn by some computer programs. Okay, so that is raster map. So basically we store the map into a pixeled image and store them using a raster tiles. So the second format is called vector map. Instead of store the pixel value or this image, it stores all this geometry information such as point, lines, and also polygons. So suppose you want to draw some text on the map, you only need to store some points. And if you want to store some rivers or the some other road, you can just store these lines. And suppose you want to store some like country boundaries, you want to store some polygons. So a good advantage of using this is that we don't need to store the pixel values, so we don't care about the color or other style about these geometries. We can define them ourselves when we render the map. For example, I can render the river as blue. I can also render the river as some other colors because we don't store it and we don't limit it to the pixel value. And there are a lot of many vector map formats, such as the shapefile, GeoJSON file, TopoJSON, and PDF file. For the Altair, we use a TopoJSON file. That's going to be the second thing you need to know about the geospatial data. So the TopoJSON format you can think of is a vector map geometries. It stores all these point lines, the polygons. If you want to know more about it, you can go to this specification, which let you know what this keyword means in a TopoJSON data. And also there is a good introduction tutorial to let you better understand these arcs in the TopoJSON data. But for our class, I think most of you only need to know one thing, this object. So each TopoJSON file contains one object. For example, this object means its object in a state, and it contains all of other attributes, and you need to find the name of your object and send it to your Altair program. And there also another important thing is this data sources. In order to find this geospatial data or the TopoJSON file, you can go to this GitHub page. It has all the TopoJSON for the United States, all the states you can see here. It also has TopoJSON for other countries such as India, Italy, Japan. All things are here. You can just download it. Another easier thing is even you don't need to download it, but use their URL. So use the trick we introduced before. Just click this roll button, and you can just copy this URL to your streamlit Altair program. Okay, so once we learn this part, let's see the last part you need to know about geospatial visualization is the map projection. So once we have the data, how to draw them is through this projection function. There are different projection methods, and what does this mean? So projection basically means we want to flatten our globe surface into a plane because the map is actually on the Earth's surface, so it's a sphere or eclipse, right? So it's a 3D object. We want to draw it using a 2D plane, so we need to map it to a 2D surface. So there are a lot of different projection algorithms. So I think this one is what we most commonly use for our navigation software such as Google Map or Apple Map. We also have other projection methods that you can use for your geospatial data. So one thing you need to know is that there is no perfect projection. It's all based on your purpose, because in some scenarios, a specific projection is better than the other one. And altair supports many commonly used projections, and we will use the one it's used by default to render our map. Okay, so once we introduce this geospatial map, now let's go back to our interface and see how to create this geospatial map. Okay, so let's go back to our program. And in order to create this program, first of all, we need to specify the layout. Because for this row, the second row, we are trying to draw two different maps here. One is the geospatial map, the other one is a line chart. So in order to do so, we need to create two columns. So use the trick we introduced before. We can type two columns here and specify an array. So as you may see here, this geospatial chart is a little bit smaller than the right part. So we're going to specify the first part as 1 and the second part as 2. This is going to help us to determine the size of these two charts. And the next step is to specify the width context with chart 1 and draw our geospatial data. So in order to do so, the first step, you need to specify the URL of your geospatial data here, and then we can copy it. And the second step is going to specify Ohio State. We can define a variable and call this altair topo feature function. And the first parameter here is the URL, and the second parameter is going to be the object name in your topo.json file. So if we go to our topo.json file here, and we can just find the object here, and the object name is the next string here, called CB 2015. It's going to be a string. And given these two things, we can import this topo.json file to our program. So, and let's try to test it. So I'm going to use sd.text. And actually, let's use this Ohio State and see if it successfully loads our topo.json file. And go back to our program here. So if I refresh our app. Okay, so you can see here, it's already loaded this map and shows the features and type and also your URL here. So the next step is going to draw this one. So the altair provided a way that allows you to draw the map directly, but more importantly, what I want to show you here is that how are we going to combine this data with our Ohio county's data. So in order to introduce you how to do it, let me first open a web page. This one. So this is the altair example to draw a map. So you can see, first of all, we need to specify the URL. That's what we already did. And in order to draw a geospatial map, you need to specify this geoshape mark. And the encode here is a color, which is corresponding to the rate. So rate is a quantitative data in this dataset. And it tries to use this transform lookup function, which tries to combine the external source or external data with this geospatial data. Because this geospatial data only defines the geometry, it doesn't contain any other data such as this quantitative data or the cases data, the daily death data in our dataset. So we need to use this lookup function to combine two datasets together. And we need to find a common key to use as this lookup key. So let me try to write some code and illustrate how I'm going to do it. So go back to our program. What I'm trying to do is to copy some code from what I wrote before. So let me explain it here. So first of all, we're trying to create a map. And important thing here is that, first of all, and sorry, in order to illustrate it, maybe I can do a simple test to make you become more familiar with this geo shape. If I just remove this part and refresh my page by add this one to my streamlit. So we will use this streamlit altair chart, and this is called Ohio map, and use container width equals to 2. So that is what we learned before to create a visualization in your streamlit. Okay. So now we have our Ohio geospatial data. And then let me delete this part. So the next part is how I'm going to connect this data with this daily cases data. So let me show this data again. So this is called, sorry, sd.data frame. And this is going to be our data.head file. Okay, so I'm going to show 5 rows here. So now you can see this is our data with this cases and datasets for the accumulative scenario, and we are trying to combine these two data together. And what are the common key we can use here is that for each row here we have a county name, and also we have this fifth number, and also in our topo.json data we also have the same attributes. One is called the name, as you can see here we have this county name, and also we have this geo ID. So the geo ID is equals to the fifth. The name is equal to, sorry, go back to the program. I'm messing up. So the name is equals to this county. Fifth is equals to the geo ID. So I need to use these two values and combine them together to form a lookup function. So what I'm going to do is, first of all, I'll create a function here. It's called transform lookup function, and put it here. And for this lookup function, I will specify the lookup property in my original data, which is the geospatial data. So this is going to be, so if we go back to the topo.json data, so we have this geometries and type. These are highest level. So let me think of how to make it become more apparent, because currently it doesn't have a structure so you can really understand. So let me download it and put it here. Okay. Drag it to the here, and now you can see this data already be structured, so you can see a lot of top level attributes. So we have this object, and we have a lot of top level such as this type and geometries, and also we have these properties. So what we're trying to get is this properties.name. So I'll specify the lookup key here is equals to properties.name. And next, I'm going to specify the other data source using this from keyword. Sorry, from hyphen equals to altair lookup. This is going to be the lookup data function. And we need to specify 3 parameters here. The first one is going to be our data is going to be used for our map. So it's going to be the current data. And the second one is going to be the attribute, the key name. We're going to do the lookup. So the properties.name is equals to the county in our data. So we will set it to county. And finally is the data range we want to join together. If you're more familiar with database, we are trying to do a join operation. So this is going to be the key or the column names we want to extract from our Ohio County CSV. So I'll just copy all the data here. So I'm going to use this current data.columns. Okay, so in case some of you may forgot this current data, so the current data is actually what we filter from this slider. Okay, So that's what we need for this lookup function. And since I missed something here, transform lookup. Not sure what happened, but I believe okay, so I have this transform lookup. So maybe I missed something here because I haven't specified the color inside this one. Yeah, so in order to encode our map, let's specify this color equals to the cases. So it's going to be art.color, and here, because we're going to use this Ohio cities data, and we're going to use this accumulative cases as our color, map these cases from a quantitative value to a color map. So we'll specify this one as cases, and this is quantitative data. So that's what we need for this color. And another thing I need is this, I'll add some interactive feature using this tooltip, which equals to, so I'll show the county name here. And the county name, as you may know, is this nominal data, right? So we also have this cases, which is quantitative data. So now we have our tooltip, and it still didn't really fix it. Let me check what happened. So it says this one was not closed, but I am actually close it. Not sure what happened, but what I can do is to do something like this. Project. So if I just remove this one, does it still give me the error? Unfortunately, yes. Okay, now we don't have the error. That means the error is coming from the inside part. So first of all, I have the lookup, which should be fine, but the second part, which may not be fine. Yeah. So we try to reduce our error range. So the second part is form equals to art. Oh, sorry, here I should use dot rather than equal. So now I have this one, and what I can do is to refresh my program and see what does it look like. So data frame has no attribute column. So what happened is, yeah, so this one should be columns. This is the keyword. We're trying to get all the columns in this data. Okay, so we have another error here, and it didn't really tell us why. So we need to think of it. So we have our encoding. So there must be something wrong here. So which means we didn't really find our data. So the current data, let me try to print the current data here. So it has a county, and the county should be correct. Oh, I see something wrong here because this name should be uppercase. So we should have this name. Okay. And refresh our page. Okay, so cool. So now we have our geospatial data, and also we can change this map by drag this data slider. As you can see here, we have a different map. So this is the first several days because we only have several counties reported as their data. So we only have several counties. Okay, so now let's try to create our second visualization, which is a line chart. This is kind of is relatively easier to this geospatial data. So let's comment or delete this part and draw our second chart. So for the second chart, in order to draw a line chart, what we can do is, first of all, let's see, because we're trying to filter some data here through this selection box, the time and the type. So we actually want to create a filter data. So in order to do so, let's do something here. Before we write the rendering part, we can do some data pre-processing to deal with our filter data. So in order to do so, let's first look at our first widget here. This is going to be a selection box. We have all counties and as well as each counties. So what we can do here is to add a if statement, because if the county is equals to all counties here, then we will filter this data, let's call it the county data, equals to date.groupby. That means we want to show a summarization data. We want to do some data transformation. We want to group our data by the date. So we use this pandas group by function and use the sum function equals to reset index. So this is going to help us group our data. Else, we're just going to filter our data. Data equals to data.log. County equals to county, because this is our selection. Okay, so if I'm going to print this one, frame, and let's show this county data and see what does it looks like. So if I refresh the page, so it shows me all the summarization data. As you can see here, it adds all the data together by all counties. If I select a specific county, it's going to give me a smaller number because it didn't really try to summarize all the data together. Okay, so the second widget is a time widget, because we're trying to get a time as for all time or last 90 days. So how we're going to do this is, after this filter, we do another step of filter. So first of all, we need to know when it's the what's going to be the past 90 days. So in order to do so, first of all, we need to get the maximum date, which equals to data date.max. This is going to give you the max date. And let's add another one called past 90 date equals to max date. So we can do some date operations here, equals to data time. So I think I imported this library, yes. It's called time delta, and we can add a parameters equals to 90. So this will help us to determine what's going to be the start date of the past 90 days, okay? So if, then we can determine whether this time span is going to be a last 90 days or something else. So actually we need to remove it here after our second widget. So once we got this option, so we can determine whether this all time. So the all time we don't need to do anything else. So we can just specify our filter data equals to county data. This is going to be our county data. And else, we're going to do some filtering operation. So we're going to make this filter data equals to county data dot log. So county data date is larger than the start date of past 90 days. Okay, so let's try to print it here. It's got to be the filter date. Okay. So now we can see if I choose this 90 days, it only shows me several rows rather than the whole rows, right? So this one is much larger than this 90 days, okay? So the last step is about our third widget. So in order to filter this widget, what we can do is to determine the data type here. So, but actually we can determine the data source in our rendering program because we can specify which column we want to use for our encode here. So let's draw this chart. So uncomment this with chart 2, and also let me remove this data frame. Okay, so for this chart, let's draw a line chart. So in altair, the way we draw line chart is to bind the data source equals to filter data, because we already filter data through these widgets, and specify a marked line. And for the marked line, we're going to set a set of encodes. The first one is going to be the x-axis. So the x-axis, we're going to encode our date. So the date is going to be a time data, so we use this t tag. So after that, we can specify the y axis. So the y is equals to r dot y, and it's going to based on our daily type here. So because we can choose either daily cases or daily deaths here, so it's going to be our type. And if we do so, the next step we can do is to add some tooltip. So we can add a tooltip here is equals to date, and also show the daily type number. And we can also specify some properties for this chart, such as the title of this chart. So we can call it title equals to daily. So we can actually use this variable as a name. Daily type plus in, and also another variable is going to be the county we selected, right? So, and finally we can make this visualization become interactive, so we can do some zoom in and zoom out operation. So let's bind y equals to false. That means we only allow this horizontal zoom in operation. So if I refresh the web page, oh, I forgot to add this one to my streamlit. So I use this command and add this line chart here. So let's refresh the page. So now you can see this line chart shows here. So if I select a different county, for example, it's Cuyahoga, and select last 9 days, you can see a more specific data. You can also choose deaths as your example in your data. You can choose daily cases. It will give you different results. So that is our second visualization. Now let's think of our bottom visualizations. So in order to do so, first step, let's create another dashboard. So we already have our first dashboard. As you can see here, using the with command, we can just fold some code here. So our second dashboard is going to be the OSU panel equals to sd.container. So what we can do here is that we can use another with. So this is going to be OSU panel. And under this panel, let's first look at how many columns we want to have. So if we look at it here, at least we need 1, 2, 3 columns plus 2 white space. So but maybe here we don't need white space because the the altair already provided white space between each visualization. So what we can do is we can specify 3 columns here. So let's first define column equals to st, but here for now we only need 3. So based on their ratio, I define 1 for 1 because the center one is going to be the largest one. Okay. So the first thing I'm going to do is for the first column, because we're going to show some data. So you may ask me where I can get this data because you didn't see this data here, right? So actually this data is also come from our data folder, but I haven't imported them because I think this data is somehow too simple and not worth to import it directly. So for example, let me open it one for you. I'm going to find the data. Where is it? Give me a second. Should be here. Go to my COVID-19 data. Yes, I got it. Okay, so for example, the new cases, the OSU only provide us with a single scatter value, so there is no need to really import them. So I just type this in on the left part, and let's see what happens. Okay, so first of all, because this text has some styles, so we're going to use the markdown grammar we learned before. So I'll just copy some code I wrote before because all of these are exactly the same from the previous one. So I'll copy some markdown. So as you can see here, first we specify a span, last 7 days, and we specify the color and the font as well as the background of its parent container. So if I refresh the page here, it seems it didn't show because I forgot to save the program. So if I refresh the page, now you can see the left side we have this maybe another dashboard to show all the cases, tests, and the positive rate. So the next step is going to create the center visualization. So similarly, this is going to be a bar chart. So what can we do is, so first of all, let's specify another width context. And in this time, we're going to use the column 1 and create the visualization through the altair. So in order to create a bar chart, what we can do is to write alt.chart, and this time our data is going to be the OSU data we loaded before, and this is going to be the mark bar and encode. So the x is going to be art.x, and this similarly we have our date, which is t tag, and for the y-axis, sorry, y is equals to lt.y case q here. So, and we also want to add some tooltip for the interaction. Maybe you can just show the date as well as the case. This is the encode, and we can add the properties here. So let's just copy some code from the previous one. Okay, so we copy the code from the previous one, and here this one should be daily cases in Ohio state. And yeah, that's all. The last thing we need to do is to add it to our streamlit. And refresh our web page. So altair has no attribute x. Oh yeah, this should be the uppercase. As you can see here, a lot of things are uppercase, lowercase sensitive, so you need to make sure you didn't make errors. So now we have this bar chart. So another thing we want to do is to add an average line here. In order to do so, what we can do is actually create another chart here. Let's call it line equals to art.chart. Here we use OSU data, and we use another mark called ru. This is going to give us a single line. So we can specify the color here. So we can use our OSU color. So it's going to be our this color. And next step is going to encode this data. So the y is going to be, let's use some transformation because we want to have the average of our case, and this is going to be a quantitative data. And the size of this line is going to be, let's set the size of this line, go to size value. So that is our average line. We can also add a tooltip. So let's copy the code here, and this is going to be our mean case. So in order to combine these two visualizations together, we can specify a chart equals to bar chart plus line. That's going to be the overlaid layout. So let me replace this one with chart and let you see how it looks like. So now we overlay these two charts together. As you can see, the average is 94 for the spring semester. So we have the center bar chart. So in the final step, we're going to create our donut chart to show this vaccination rate. So we can specify columns 2 using the with context. And first of all, I'm going to add another markdown grammar because I'm going to show this vaccination rate we calculated before. So this will provide us another title here. Vaccination rate is equals to 0.93. Okay, so then we can draw our donut chart. In order to create the donut chart, we can create a donut chart using the altair chat function for chart, and the data is going to be our vaccination data. And for the mark, here we're using the arc mark, and let's encode the data here. So we will need some parameters. The first one is called theta, which means the portion of our data. For example, this uncount has this portion, and the rest, or the vaccinated population, has the largest ratio. So we'll use this theta equals to r dot theta, and the field is going to be the value because we want to map this value to the area, or actually the arc length. So, and the type is going to be quantitative. So all of this is a little bit from other altair chart, but you just need to understand and follow this grammar. So for the color, it's going to be color and field equals to category, because the color is based on the category of the type, and the type is a nominal data. We only have 2 types. So it's going to be the nominal. And finally, we can have a tooltip as well. So let's call the tooltip equals to category and value. So now we have our donut chart, and let's try to show it here. Refresh our web page. Oh, actually, it only shows you a bar chart, because the difference here is we forgot to change this one to donut chart. My bad. So, oh no. So now you can see there is nothing here. This is because we haven't specified the radius. So we're going to specify the inner radius equals to 70 for this chart, and refresh the page. Now we can actually see a pie chart. So the reason of this is because the legend position is not correct. So we need to add some additional legend parameters for the color. So it's equals to art.legend, and we specify the orientation of this legend to be, the position of this legend be on the top, and the direction is going to be vertical. That means we want to, so actually this will give us a legend look like exactly the same with this one, but we'll try to force the Vega or the altair to relay out this pie chart to a donut chart. So if you refresh the page, now you can see the donut chart here. And the next step, I'm going to remove this boundary here because it's kind of ugly. So I'll add another one called configure view, and equals to stroke width equals to 0. That's going to help us remove the border of our Vega, altair chart. Now we have our OSU, actually this is the dashboard for both Ohio State and also the OSU. So we have this map, geospatial map. We also have this line chart to show all the counties. We can change different days. We can also have this OSU daily cases data as well as this donut chart data. So this dashboard contains 4 different visualizations as well as 4 different widgets. It will help you to interact with your data. As I said before, this is not the perfect solution, but it provides you a starting point to your final project. I hope this lecture could help you in your final project. I didn't really deploy this program, but I believe once you got my code, you can deploy it to your GitHub account. So that's all. Thank you.